We Our platform is a blockchain as a service um, product, which basically is a bridge from 3.0 to 2.0. So basically, you can leverage our product to build blockchain applications within a 2.0 environment. So I'll try to keep this short, 5-10 minutes, and we'll try to have a conversation rather than what this is capable of. And I'll be sharing some use cases, real world use cases where blockchain can be used, and we'll have a conversation about where can you use blockchain in your world, right? And we spoke a lot today about, I think every speaker who came in on the stage today spoke about AI, and I would like to dedicate the second half of the conversation to speak about what blockchain can do in the fast evolving AI world, right? So that's where our latest API family that we've come out with. So to begin with, I'll play this video for you guys, which hopefully will give you a good introduction to the platform. Tell me if you can hear it.
Fast-paced and interconnected world, businesses face a wide range of challenges that can hinder their growth and success. From supply chain inefficiencies to financial fraud, companies must constantly adapt to new obstacles in order to stay competitive. Blockchain technology can help address these challenges by providing a secure, transparent, and decentralized way of tracking transactions and data. With blockchain, financial institutions can streamline transactions and improve security.
I think it's not streaming because I have it on my phone. Hopefully, we have a resolution to the back.
In today's fast-paced and interconnected world, businesses face a wide range of challenges that can hinder their growth and success. From supply chain inefficiencies to financial fraud, companies must constantly adapt to new obstacles in order to stay competitive. Blockchain technology can help address these challenges by providing a secure, transparent, and decentralized way of tracking transactions and data. With blockchain, financial institutions can streamline transactions and improve security, while EV companies can improve charging networks and provide proof of sustainability. In the supply chain industry, blockchain can help reduce the risk of fraud and errors, and improve the efficiency of logistics and inventory management. FlexBlok is a blockchain-as-a-service platform that can help businesses of all sizes harness the power of blockchain without the hassle of building and maintaining their own infrastructure. With its rich out-of-the-box utilities and APIs, FlexBlok makes it easy for traditional web developers to build and deploy feature-rich blockchain applications. In a world that's rapidly moving towards Web 3.0, FlexBlok is your quickest path to blockchain with zero pain. FlexBlok. The next, everything.
So that's a brief intro into our product there. Sorry for the streaming. I can send that link when bandwidth is better. You'll be able to see it in better resolution there. So I'll quickly get into the slide deck here. I'm going to skip the introduction that you guys got, and get into the little bit about the platform of what this is about. So we've basically taken the Hyperledger Besu open source platform and enterprise hardened it, developed some utility APIs, and then our USPs in the solution layer APIs. Now, if you were to be a typical Web 2.0 enterprise wanting to leverage blockchain, if you were to take up the Besu platform or any of the Hyperledger open source, there's a lot of effort that one will need to put in. You're looking at standing up a team of close to about 6-8 engineers, infrastructure, and a time period of about 6 months, right? So even if you would like, if you want to just back up a blockchain data, the way you end up doing a backup of the blockchain data is very different. So likewise, even if to stand it up, to spawn a network, you need a lot of scripting that needs to happen. So we've handled all of that in the utility APIs. If you were to even get past that, right, how do you develop a solution leveraging blockchain technology? That's a big challenge because that's a paradigm shift. Now, for those of you who are new to the technology, blockchain is, think of it like it's a ledger, it's a write-only ledger, and you cannot edit, right? You cannot delete. You can only append data to it, right? So that's where the security comes in, that no one can muck around, no one can tweak the data. So if there is any change in the structure of the data, then it doesn't reconcile, right? You're having it and you have distributed this ledger amongst your participants on the network. So if you're a consortium of 4 players, all the 4 players would have a node and would share this ledger information. So there's no one party can change the data. So the trust is in the system and not the players, right? So that's the fundamental technology that blockchain offers, right? So what we have done is we have built solutions for decentralized ID. We built solutions for document tracking. We built solutions for data tracing. It's basically data provenance, and smart contracts. We've kind of evolved the standard solutions there to adapt it to various industries. I'll talk about those a little bit. So this is basically at a very high level an architecture diagram of our platform. It can be deployed on AWS, it can be deployed on GCP or Azure. So within a matter of 30 minutes, we can stand up a whole blockchain network ready to, ready for use for in an enterprise, scale, right? So just a few points here, right? One of the USPs I would stress upon is I would say two important USPs. One is the rich set of APIs to get your application up and running. We typically claim that within about 8 weeks you could have a solution up and running for any of your use case, for one use case, right? So basically friction is less, time is less, cost is less in terms of getting the solution up and going. So this is a comparison of from a time and effort perspective, cost perspective, opportunity cost that you're losing if you were to build your own solution, kind of a scenario. Very simply put, if I have to give you an analogy, today if you were to go and build a payment gateway, right, very similar to how Stripe is, you won't do that today because you would end up using Stripe's API and integrate it for your payment gateway. That's what we want to be for blockchain, right? We want to be Stripe for blockchain, and that's our goal. So getting to the use cases, which is the most interesting aspects, before I get into that, any questions regarding what is blockchain at all, or regarding our platform, or anything I shared so far? Yes.
Question for let's say, for example, for you mentioned payments application for transaction speed and volume, what type of, are you using Solidity?
Yeah, so this is basically Hyperledger Besu, which is the Hyperledger Besu is the underlying technology, which is basically on Ethereum. So this is private blockchain deployment, so there's no gas fee that you need to pay for, which is in a public blockchain you end up paying. So that's one big difference between us and any other blockchain platforms that are available there. The second one is you could deploy it within your enterprise network, right? You don't have to put this data out in the public domain, right? So if you have a consortium where a supplier and a vendor situation, and you have multiple suppliers, right? and let's say 2 or 3 buyers are sharing a set of suppliers, and you want to have that consortium network, this is a great solution, right? So for this, a good example is this is already deployed in the industry. In the pharma industry, this is really taken off, this kind of deployments. So if I were to give you an example, Merck, Pfizer, AstraZeneca, and I think one more pharma company, they've come together and formed a consortium called MediLedger, right? So they are trying to address the DSCA 2.0 regulation from the FDA, which is every drug that is manufactured today, you need to have supply chain data provenance from the point where the raw material was sourced for making any of our drugs today. So the compliance deadline was last November, but I think none of them were able to meet. But at some point in future, you're going to have a QR code on your drug, and you as a end consumer of the drug can scan and figure out what was the chain of data or where did the raw material get sourced from, right? Or even from the point of manufacture till it reached your CVS or a Rite Aid store, you would see you will be able to view the data provenance. So just giving you one of those examples of where it can be used. It's not a public blockchain, but a blockchain owned by 4 large pharma companies, and all the vendors who are participating in the ecosystem are part of that network, right? And they're sharing data and collaborating amongst themselves in that ecosystem, right? If you want to stand up such a ecosystem, we do provide that kind of technology platform here. This particular use case is a decentralized ID use case. What we have here is, if you were to take a scenario where you have a university and you have students in that university graduating there, and the university has to, each time a student goes for an employment, there's a verification, right? So they go through a background check, and what happens in a background check? The employer hires a background check verification company, and that company in turn goes to all the universities that the student has studied and gets a verification done, right? It's a tedious process, time taking, repetitive in nature. In this scenario, the student and it's centralized, right? Because there's one entity that is verifying this particular student studied here, and it's not the student is not in control of the whole data flow. In this scenario, what happens is the student initiates what is known as the verifiable credential, and the university verifies that at one point in time, and the student can share the certificate with the employer, and the certificate itself is self-validating, meaning the university, the student, and the employers are on the network, and they don't need to go do a physical verification because it's a digitally verified signature, right? It's the encryption within the ID that is being shared itself verifies, right? So it's instant, right? And there is no central authority that is validating it. The system is validating it here, right?
In that case, I saw the student has the wallet, so
they will have a wallet, yes.
So they're the ones who would hold that, and
Yeah,
then they would share
yeah,
it with them.
exactly, right? So you can extend this to various other things. It could be your health record, exactly the same thing, right? So if you were to extend that use case to, let's say, you're going to you have a cardiologist, you have a nephrologist that you're visiting, right? Or pulmonologist, whatever that specialty is, and there are certain elements of your health record that you do not want to share, or they don't need to know, right? Today, your health record is just out there in paper form, and you give it to somebody, it's gone. You don't have control over it, right? You don't know who all is looking at it and what all information is being shared. You don't know how the insurance companies are evaluating your health record, And when did they look at it? How many times did they look at it? Absolutely no control, right? But if the electronic health record were to be on the blockchain, hypothetically, you could share elements of your health record, right, to the concerned specialist. You could actually track how many times it was viewed, and the person who actually is authorized to view it will be the only person who can view it, right? If I'm given your record, I cannot give it to Subbu to look at it because the tokens are going to be different, right? So you can control that. You can control the time period, right? If you were to authorize me to see it for the 2 weeks, I can only see it for 2 weeks. After that, that authority is gone. So there's a lot of traceability in from that perspective as well. So that's why it puts the control back to the patient, or in this case, back to the student, right? So this is a very similar use case that I talked about just now regarding the patient healthcare data. So it could be, especially in a clinical trial scenario, right? So if a patient is participating in a clinical trial, that becomes very, very critical, right? So how is your information? You're participating in it, but you do not know how your information is being shared, right? That's a classic scenario here. And also, in what happens here is, in this scenario where there's a biotech company that is trying to come up with a new drug, right? And then there are clinical research organizations that are actually conducting clinical trials on behalf of the biotech firm. They can only see certain elements of the information, right? So especially with all the data concerns about patient data, here in the US as well as in Europe, the only way you can protect that information is putting it on the blockchain, right? So we're actually working with a French biotech consortium firm which actually facilitates that whole biotech research, right? So they actually facilitate from the point of collecting blood samples of patients, and then as it traverses through, basically that is the scenario is where a patient elects to be in a research, and he can choose what research I want to participate in, right? So maybe if you're a woman, you would want to participate in research that is helping women's health, or if there's a particular cause that you want to donate your genetical data, you could do that. And then when you've given the consent to participate, you actually get to know where your genetic data is being shared to, which companies are dealing with it, what are they doing with it, right? And what is the final outcome of the research, right? They may not publish the research data, but at least you know that you have contributed to that research. So that whole cycle of information, they're wanting to use our platform to facilitate that data handling. Given that Europe has a lot of regulations regarding patient data and all that, there's no other technology they can rely on today. So this is another one of our other customers who's used our platform. This is in the check cashing business. Subbu, you want to speak about it?
Sure. So here in this implementation, this is actually a brand new implementation where we did the application development, including the blockchain implementation. So it's literally a two-in-one for us. We started off as a software services company 7-8 years ago, and we have that expertise. And FlexBlok is a new kid on the block. Last couple of years, when we built it into the market. So in this case, what we did was there were 3 modules, and blockchain was the 4th component, backend. There's the payer, payee, and the check cashing entity. So where you take a physical check, where you issue a check, they take a physical check, a person takes the physical check to the check cashing store, takes the money and walks away. with, of course, the service fee being subtracted from the check. So, so the payer is basically the person who's issuing the check, or it could be a company which is running the checks for an employee.
Payroll.
And that will have the physical check given to a person, and if he or she doesn't have a bank account, for example, or has a bank account but needs an immediate cash, he or she would go to the check cashing store, and the check cashing store will take the identity of the person, it gets stored in the blockchain, and then it's fully validated. So this basically is an attempt to reduce the fraud that happens in the check cashing business. And as you repeatedly go and cash the check, there's a scoring system that can improve, where your trust will increase when you go to the same check cashing store. So those are some of the elements that we can do. So this is a very novel implementation, fresh off the block we did. And all the information is stored in the backend. You want to add anything, Shane?
I think you covered it all. So again, here the element is about identifying the person. The person goes through a driver's license self-validation, and their information is put on the blockchain. And as Subbu said, the check information is also put on the blockchain. So it's a dual validation of the information, so that when the check cashing business issues cash, right, there's no way of getting it back. So you want to make sure that put in all the controls before you draw the money out of your teller machine and give it to somebody. So that's basically what's happening here. So this
payee module is a mobile implementation. It was implemented on the mobile, so you could literally take a picture of it, take a picture of your driver's license, give it to the check cashing center, they put it in the blockchain, validate it, and that. So there's a web component, there's a mobile component. It's all very neatly.
This is a supply chain scenario very similar to what I mentioned on the pharma use case. How many of you bike here? Okay, so if you know about Cannondale bikes, so they're one of our customers, right? So as you all know, Cannondale bikes, sometimes the bike costs more than the car that you're driving. So, and the components are really what it costs. The frame is basically nothing, right? The cost of the frame is not much. So the idea here is they want to, a secondary market for these bikes, right, are significant. So they wanted to make sure that the original owner is able to get full value for the bike when they're ready to sell it in the secondary market when it comes up. So you could typically scan the barcode of the components, and it's already there in their system, but if you as a secondary buyer, you can go look it up and see who was the original owner, where did it get sold, which store sold it. Now the whole supply chain of secondary market was addressed, and it also goes back to the point of when it was manufactured, right at the point of the original manufacturing. So all the way through. If you take bikes out and you put jewelry there, or you put $300,000 woman's handbag, these could be of great value, right? This one is for we're working with one of the I would say incubation centers in Ohio, where it's called the Battery Valley there. LG has their battery manufacturing plant. I think Panasonic also is coming up with their plant, and SK is coming up with their plant. Of course, some American companies. This is part of the Inflation Reduction Act that brought a lot of industries back to the U.S. So one of the companies there wanted to track their battery life, and they were hitting upon warranty claims. Even if it's a stationary EV battery, right? people don't use it the way it's intended to use. So you're typically, let's say your warranty claim is, the manufacturer's warranty is 8 years. If it's not used in the recommended manner and maintained in the recommended manner, especially with lithium-ion batteries, you have a runoff condition. So if you go below 20% of the battery charge, you're supposed to be charging it back and not draining it to 1% every time, right? So what our blockchain platform is helping here is being able to track the usage of the batteries, both the environmental conditions that it is in, as well as the charging patterns and the discharge patterns, right? So this could be used for vehicles, it could be used for stationary batteries as well. So if someone is drawing power out of vehicles and charging something else, you would know because of the distance it traveled, what was the temperature it was operating in, where did it charge, where did it, how much charge was used during the travel, and so on and so forth. You can derive if there was a misuse of the vehicle or the battery, right? So that was the use case here. So now coming to this last use case, which is probably which we discussed a lot today on AI and data security and machine learning, right? So we all know that the problem that the industry has today, right? So if you're developing a data model today, or you are consuming a data model today, half of the industry doesn't know how did the data model get trained, right? Now very simply put, if you go on Google and you look for a particular content, right, the Google search engine attributes where the content came from. You know that this particular content was in the search index and it came from this particular site. But when you're generating regurgitating the content from ChatGPT, you don't know where it came from, right? And that's the problem with most machine learning models today. So how many of you are aware that New York Times actually sued OpenAI for plagiarizing their content, right? And that's a classic use case that if ChatGPT had attributed it or even tagged their whole data sets of where they're generating it. Of course, they're a big company, but if it's an enterprise is doing it, now tomorrow, 12 months later, someone comes and claims that you have used my data. How do you prove that you did not use someone else's data? It was your own data, right? So we have actually exposed two sets of API families in here. One is for the training of the data set, right, where you can, we just shown about few parameters here, but this goes to 20 plus parameters that you can capture when you're training the data model, all the way from the foundation model to the data sets that you have used, to the environment in which you trained it, right? You can tag the MAC IDs, the IP addresses, the CPU that was used to train it. All of that data, right, can be put onto the blockchain. So the more data you can collect about the training aspects, the more stronger your IP is for the data model, right? And we also provide the ability to retrain the model. So even if you're retraining it, you can track that retraining aspect. So basically you're logging every effort of training your AI and ML model onto the blockchain. Now the second set of the API that we have is the usage of the model, right? So assume that your data model is being used in an ensemble of other data models, right? And there are multiple companies collaborating here. So let's take a real example, right? So we all know that Tesla is collaborating with Baidu. I shared this example with some of you here today, but let's take that example, right? Now in the real scenario, Tesla's car is taking the image of that particular street where the car is, comparing it with Baidu's data, making a certain decision, and then feeding it back to the autopilot data model for it to guide the car, right? is a classic case where there are two different data models of two different companies, where there are different outcomes feeding one model to the other. Now, God forbid if there's an accident that happens, right? If it is not on the blockchain, these entities have all the incentive to go and change the data if someone were to audit them, right? We all know. And if you're an auditor trying to figure out what caused the accident, which data model actually gave the wrong information for the accident, there's no way to know, absolutely, in an absolute sense. But conversely, if this data were to be logged into the blockchain and it's shared amongst the regulators and the entities involved, there's no two ways about that data, right? So it's just not about having that data provenance in this whole AI ecosystem that we're talking about. It's also about monetization. In the same case, one can actually track how many times the Baidu model was called or other models were called in the ensemble of data models if it were to exist. So that's, I think, where the value add is coming in. So all our APIs today integrate with Hugging Face. So if you have a foundation model or you've derived a model from the foundation model, we can track that entire data set, we can track the foundation model, we can track the data sets, you can track the data sets that you're training it against. And if you have put out your fine-tuned data model on Hugging Face and someone were to use it, you would know the attribution of usage. Right? So that's our latest offering. We don't have a customer yet for it. We are in discussions. Happy to, if anyone wants to give it a try, love to share it with you.
So who's buying this in this model, in that scenario? That example, you have Tesla and the partner. Whose incentive is it to use blockchain?
I think it is the incentive for both these entities to use it,
Okay.
as well as the regulators to use it.
And
In that particular
I hear
example.
what you're saying, and then I'm putting on my lawyer's hat, and I'm saying I'm a lawyer for one of the two parties,
Mhm.
and I want to do nothing but create potential confusion versus identifying. Okay.
So I think the blockchain is only solving the point that the data that you're seeing, irrespective of whether you use blockchain or not, there's a certain data flow that's happening anyways, right? There's certain integration that's happening anyways. All we're doing is sipping into that transaction flow and saying put it on the blockchain so that there's a log of the flow of the data, and it's basically data provenance saying that no one else mucked around with it, right? That's all it is.
Right.
If it's garbage in, it's garbage out even here.
Right.
But you have the log of that in terms of in every way.
And the stakeholders have access to it.
Yes,
All the
yeah.
stakeholders have access to it. That makes it transparent. So that is a proof
Yeah.
that there is no tampering.
Yeah. Rebecca?
In, for example, audit verification, you're talking about licensing and monetization. I'm very familiar with different protocols for IP, NFT. Basically they put the license in the block,
Right.
and then the software actually manages the royalties around that.
Mm-hmm.
So is that something that your deployed models have capability of doing? Because I've seen other.
We have done a different use case there, where our customer has a product that solves the paywall problem, right? So if today if you have, let's say, take an example of Visa, their end customer, one of the end customers is Visa, and they have marketing analysts, right? They have 50 odd marketing analysts covering various industry verticals, right? And they all need content on a daily basis to look at. So they're probably reading Bloomberg, they're reading Wall Street Journal, they're reading all these online publications, and all these publications are tuned for individual subscriptions, right? So you got to give out your credit card and so on and so forth. So our customer solves that problem of paywall. So for an enterprise customer, they can buy, they just subscribe to our customers, they buy X number of licenses from our customer, and they arbitrate the license. So they act as the man in the middle. But what happens is they're buying X number of licenses from Bloomberg, and Y gets consumed by Visa, right? And Y dash gets consumed by some other end customers. So there's a reconciliation of these licenses. There's a license usage issue here. So Bloomberg has no actual visibility to actually who's using it, because it's all hidden in this paywall thing, right? So what they wanted to do was solve that problem. They wanted to build the trust with the publishers. So what they're doing is they're putting the data of the consumption and the license usage of their end customers on the blockchain and exposing that to the publishers. So now the publishers know at the end of the month, if they are getting paid for 150 licenses, they exactly know that yes, 150 licenses were used this month. Next month it drops to 120. They know that there were 120 only, right? It's not that someone is making up that number, right? That's number one. Number two is, moment you start attributing the usage, right? You know the pattern of usage, right? Tomorrow cookies goes away, you have the whole attribution of how someone used the Bloomberg in Visa, right? And that's undisputable information. Advertisers today, just rely on whatever data they get. But if it's on blockchain, imagine that's worth in gold, right? So that's what they're going after.
So in public blockchain, there are miners who validate a transaction, right? So how do you
It's a consensus algorithm. It's a consensus algorithm, yeah. So what happens is you have basically mining happens, right? So there's proof of stake, proof of work, whatever that is. So here also the consensus algorithm is at play, but it's those nodes, right? So if you have a consortium, the one that I explained to you in the pharma use case, if there are 4 pharma companies and a regulator, these 5 become the consensus transaction settling nodes, right? So it is within this closed loop of within this who's part of this network, they become the
So you need at least more than one member who is...
Yeah, typically recommended practice is to have 4 nodes.
4 nodes.
Yeah, you could host all the nodes if you want, if it is completely private, but if you have a partner, then you can share one of the nodes with the partner. So you have that ability. Good questions. Any questions here? Okay. Thank you very much.